Hey, MathKook here. This video contains one of many examples in my Algebra 2 library. The rest of those examples, along with hundreds of other videos, are only available at mathkook.com. Let's MathKook it up. This question says, find the vertex, whether it opens up or down, axis of symmetry, x and y intercepts, max or min, domain, range, and intervals of increasing and decreasing for the quadratic function, g of x equals negative, x minus 2, x minus 8, then graph. All right, so let's jot down everything that they are asking for here. So they're asking for a lot of items. Now, taking a look at our quadratic function, what form is this quadratic function in? It is in intercept form. So the intercept form gives us the two x-intercepts of the parabola, so which are r1 and r2. Let's bring down our graph here, or our function. And in this case, who are R1 and R2? So R1 is going to be 2, and R2 is going to be 8. It's always opposite of whatever's here because it's the negative in the equation. So that tells us that our x-intercepts are going to be 2, 0, and 8, 0. All right, so I'm going to write those over here for our x-intercepts. Now let's find our y-intercepts. So to find the y-intercept, we plug in 0 for x. So wherever we see x, we plug in 0. All right, so g of 0 is going to equal negative. 0 minus 2 is negative 2. 0 minus 8 is negative 8. So g of 0 equals negative 1 times negative 2 is positive 2 times negative 8 is negative 16. So our y-intercept is 0, negative 16. Every y-intercept has a x value of 0. All right, let's go ahead and erase this. And next we want to find our vertex. So the vertex, whenever you're given intercept form, the best way to find the x value of the vertex, or h here, is adding the two x-intercepts and dividing by 2. So we're taking the average of the two x-intercepts. And the reason why is because graphically, if you have a graph that, let's just say, potentially looks like this here, and your x-intercepts are here and here, the x value of the vertex is going to be right between, equidistant from these two x-intercepts. So that's why we take the average of them to find the x value of the vertex. So let's go ahead and do that. So h is going to equal r1, which is 2, plus r2, which is 8, divided by 2. 2 plus 8 is 10, divided by 2 is 5. All right, so we now know the x value of the vertex. So there's the x value of vertex. Now we're going to find the y value of the vertex. So all we do is just plug that in to our function for x. So it'll be g of 5 equals negative, and then 5 minus 2. All right, then we simplify. G of 5 equals negative 5 minus 2 is 3. 5 minus 8 is negative 3. So we get negative 3 times negative 3, which is positive 9. So that tells us our vertex is 5, 9. So we'll go ahead and write that over here. 5, 9. All right. Now we can ask ourselves, does this parabola open up or down? Well, because there's a negative, so a is negative here out front. You can see that here as well. So because a is negative, the graph is going to open downward. So it's going to look like this here. It's going to open down. So I'll circle that over here. Our axis of symmetry is always x equals whatever the x value of the vertex is. So in this case, the x value of the vertex is 5. So the axis of symmetry is x equals 5. All right, and then we have max or min. So our max or min, in this case, because the parabola is opening down, are we going to have a max or a min? Well, we're going to have a max because the highest point here is the top or the max. And the max is always the y value of the vertex. Really, or the minimum, but in this case we have max. So it's always the y value of the vertex, so it's going to be just 9. All right, we will find the rest of these items after we graph. So let's go ahead and erase our work here and bring up our graph. All right, so let's graph our vertex first. So we have 5, 9, which is roughly here. And then we have x-intercepts of 2, 0 and 8, 0. So we'll graph the 2, 0 first. 8, 0 is over here. And the y-intercept is 0, negative 16 here, which goes beyond the graph. So it's probably going to be fairly steep there. So we'll go ahead and graph this here. There is our parabola. And if we graph the axis of symmetry on here, x equals 5. So it goes right through x equals 5. So this graph here is x equals 5. And then our vertex, put a v here, is 5, 9. All right, now we have to find our domain and range. So domain is all the possible x values. And this graph goes to the left forever and to the right forever. And so there's no restrictions on x. We can plug in whatever we want. So negative infinity to infinity. The range starts down here. And it is defined at negative infinity because this graph goes down forever. So it'll be negative infinity all the way up to, and then the very top value is 9 for the y. So it goes negative infinity to 9. And the 9 is in brackets because it includes 9. This point right here is defined. Okay, next is increasing. So the graph is increasing when it's going up and to the right. So that occurs all here. And this goes up and to the right really starting at negative infinity. So it's going to be up and to the right all the way to here. So it'll go from negative infinity all the way to 5, where it stops increasing. So we have negative infinity to 5. And then it decreases starting at 5, and it goes down and to the right here forever. And this goes to the right forever. So it starts decreasing at 5 and continues to decrease for all x values to the right. So from 5 to infinity, it decreases. All right, so we've answered all the questions they've asked, and we've graphed our function here. Let's look at another example. Hey Kook, if you found this video helpful, hit that like button, subscribe, and drop a comment. For unlimited access to all of my Algebra 2 videos, visit mathkook.com. Thanks for watching.